Hello, class. I thought today that we would go ahead and do our Tuesday review. I had it opened and I opened it again. Here we go. All right. So the first question has to do with even odd functions. So if a function is even, that means you put in negative x and you get the same function back. If a function is odd, then you put in negative x and you get the opposite or the negative of the function back. Now, looking at this, if I put in negative x, it's going to change the 8x, but it is not going to change what's in the absolute value. So this one is neither even or odd. Okay, on the piecewise function, x is negative 3 on the first one, so that means it's less than 0, so that I'm going to square it. So negative 3 squared is positive 9. If f is 0, if x is 0, then f of x is 3. And then if x is 4, then f of x is greater than 0. So 4 times 3 plus 1 is 12 plus 1 is 13. So you have to know what particular piece of domain it's in and then find the solution. On number 3, write the function whose graph of y equals x cubed, but it is shifted up 8 units. So any shift that is vertical on your functions is just going to be like it's added at the end. So this is going to be y equals x cubed plus 8. And that's all there is to that one. If you had a horizontal shift, you would subtract it before you cube it. That'd be like on the inside. All right, I'm looking at a table on number 4, and we just want to know if it's linear or not. We don't care if it's exponential or quadratic. Just is it linear? So I notice that x goes up by 1 each time. So if I'm adding or subtracting the same number each time, it's linear. If not, it's not. So here I'm adding 5, then I'm adding 3, so then I know it's not linear. If it's linear, I'd have to check every one of them because they may sneak it in at the end. All right. Here's a scatter diagram, and it looks very linear. The one I looked at earlier looked very quadratic, so this one would be linear. But they just want linear or nonlinear. A vertical line passing through the vertex of a parabola is called your axis of symmetry. And then the last one is the line of best fit. So what you want to do is you want to get your calculator and put in your data. So get your TI-84 out. And I'm just going to go to Stat, Edit. In L1, I'm going to put the X values. So that is 2, 4, 4, 6, 8, and 10. I think sometimes you can just type it in the keyboard. Okay, and then the Y values are L2. So that is 9. Yeah, that works. 13, 12, 15, 16, and 20. Yeah, a little bit faster on the keyboard. All right, I looked back and I messed up on 13 and 12 up here. So I want to fix that. You always want to double check your numbers. And fortunately, this is going to be a small enough number set that it will be easy to check. And I guess I have to enter it here now. 12. Maybe not so fast. Okay, so 9, 13, 12, 15, 16, 20. Okay, everything looks right now. So I'm going to go back to Stat, Calculate, and it's linear regression. I know it's 4 and 8. We just usually do 4. So you can type the number 4 or arrow down to it. Then I just want to calculate it. And then it says you want to round to 4 decimal places. So, well, that went away. See if I can't get to see both of them. Not too far over. Okay, there we go. So the slope, just make sure it corresponds. A is my slope here. So it's going to be 1.2538. Double check, make sure 8 doesn't round up. And then B is going to be 7.0615. And I double check 5 doesn't round up either. Okay, because sometimes they round up, sometimes they don't. All right. And it helps if I type the right number in. So A is supposed to be 1.2538. So I missed that number. Okay, so that is Tuesday's review. Have a great rest of your day. See you tomorrow.